In this lecture, we want to talk a little bit more about variables. Let's say we have the number 7. We want to store this number 7 into a variable for use in our program. The number 7 is an integer. We know that because it's a whole number. We also know that integers are a type of data in Java called primitive data. And remember, our loose definition for primitive data is information that can't be broken down any further. Primitive data in Java are things like doubles, floats, characters, booleans. These are the types of data in Java that cannot be broken down. They're primitives. So we want to go ahead and declare a storage location of type int, and I'm going to name that storage location R, because I'm going to represent it in this lecture by a red cup. Once I've declared my variable, I can go ahead and I can take my value and I can assign it to the R variable, and it gets stored in that location in memory. And remember, a variable is a named location in memory. Now, primitive data is handled a little bit differently in memory than objects. So once again, when we're dealing with primitive data, we create a variable for that data. What happens is that piece of information gets stored directly in that memory location. Now, let's talk about a different type of data. Let's talk about strings. Strings are a subclass of information in Java called objects. Objects are more robust than primitive data, and the best way to see that in a string is to notice that a string is composed of 1, 2, 3 characters in this case. So we could actually break this object down into more constituent parts. In other words, we could break it down into the character C, the character A, the character T. Each character in this case is represented by 16 bits in a Unicode system. So what I've actually got here is 48 bits worth of memory occupied by this object. One of the things we know about primitive values is that they take up a fixed amount of memory. So in this case, an integer in Java takes up 32 bits of memory space. Whenever we declare variables, the Java runtime system needs those variables to consume a fixed or known amount of memory. And in this case, the int takes up a known 32 bits of memory. The problem with objects is this is a simple string. It's the word cat. It only takes up 48 bits of memory. But I could put something in here like the entire Constitution of the United States. And then how many bits of memory does that take up? We don't know. It confuses the Java runtime system. Even more, what if we're prompting users to enter strings in through the scanner object, right? The variable's not going to know how big or how small or how much memory to reserve to hold the string in memory. So let's talk about how objects are dealt with in Java. I'm going to go ahead and declare a string variable named B to hold my string cat. So here is my variable. Now, one would think that all I would do is store cat into that variable, but that's not how it works. It does not work like that. All right? The idea here is that this variable needs to be a known amount of memory. Okay? It needs to consume a specific amount of memory. So how does this work in Java? Well, there's actually two types of memory in the runtime environment. There's what's called the stack, and regular variables get put onto the stack because they're known fixed sizes of memory. Objects, because they can be very tiny or very, very large, get stored in a special part of memory called the heap. So we're going to go ahead and send the cat off to the heap. How does this variable know where to find that variable? Or sorry, that value, the cat value? Well, object reference variables is the proper term for variables that hold objects. And they do not hold the object, they actually hold the memory address of where to go find the object on the heap. So what is in an object reference variable, what is in my string B variable, is a reference to a place in memory where it can actually find the value cat. So cat exists somewhere in memory, and what does the string variable hold? It holds the reference of where in memory you can find that object. And this kind of makes sense, all right, because since this area of memory that holds variables needs to be very orderly and very strict and know about size and not really mess around in terms of the amount of memory it needs to reserve, we can have a separate part of memory that's like a sandbox that can grow and shrink, and it's kind of like the Wild West. So where objects are stored in memory is kind of like this Wild West area of memory, but the stack is very orderly. It's a place where everything has a known size and a known data type. So object reference variables hold references. They tell you where to find the object in memory, whereas primitive variables tell you exactly what the value they're holding is. Let's take a look at this in a more interesting example. Let's say I have made a custom object type. This is a shoe. I'm going to declare an object variable of data type shoe, and I'm going to call it P. Now I get my variable to hold my shoe object. Notice the shoe object doesn't fit really well in my variable. The shoe is actually going to get stored on the heap. And what's going to get stored in my shoe variable? A reference of where to find the shoe in memory. And now this makes sense. If we were to sell shoes, maybe you'd have this great idea to save money that you would just make one box. And every pair of shoes that you sold would go into the same size box. So that kind of makes sense when you've got an average size shoe. But what if you also sold baby shoes and Shaquille O'Neal size shoes? All right, that means you would be, having some shoes that overflowed outside of the box. You'd also have some shoes that rolled around inside the box. That's why this works in Java this way. This idea that every variable needs to be a specific size. Therefore, when we're dealing with objects, we don't know the size of objects. In this case, the shoe could be very tiny or very big. We put that out into this special part of memory that handles these, elastic objects that can be of any size, and the Java runtime environment can adapt. But where we store our variables in memory is very orderly, and it just keeps a fixed size pointer, either a 32-bit piece of memory or a 64-bit piece of memory on 64-bit systems that represent an address in RAM or in memory where you can find the actual object that you want to reference. So when we deal with objects, we deal with object reference variables. When we deal with primitives, we deal with primitive variables. Later on, we're going to see some ramifications of this. What does it mean to pass a value versus what does it mean to pass a reference around in your code? It has some definite ramifications on how you write code. It gets a little confusing, but it makes our code a lot more efficient.